Guys, welcome back to my channel, and today I'm going to be teaching the second step of integration, which is U-substitution. This is part of Math 31, so I'll start with the first example. Okay guys, so U-substitution is could be a combination of power rule. It is a combination of power rule, so let me start explaining. You'll pick your U as something that can be simplified into whatever's outside. So if you try picking your U as 2x, it will simplify to just 2 equals 2. But there's no 2, just 2 here, right? So there's only x squared plus 1. You want to get it to equal this or get it to equal this. So if you try picking your U as x squared plus 1, we can turn this into, by using the power rule, 2x. Is there any 2x here? Yes, there is. The 2x is right here, and you want to add the dx as well. So our u is x squared plus 1, and our du is 2x dx. You want to make sure the inside turns exactly to what the outside is, and if it doesn't, then we'll have to rearrange some things. Also, I want to mention that when you pick your u, and you can probably get confused by the power. I just want to mention that you can ignore the power, look only for what's inside that can be simplified to the outside. Completely ignore the power. Okay, let me organize this a bit. Okay, so we'll pick our u now. U is x squared plus 1, and then du is just this getting simpler. So 2x, don't forget to add the dx. Now that you have your du and u, you can just substitute into the original integral. Let me erase this. Guys, now you just want to substitute the u back into the integral. Here, whatever has the power, you'll put the u there. So just put u, because it's x squared plus 1, u to the power of 3. The inside is the same as the u. And the outside is 2x dx. It's being multiplied by u, so you'll just put du on its own. Now, if you watched my last video, you remember that you'll use the power rule to integrate this. So for the power rule, all you do is just add 1 to the power, and the same with the denominator. So it's u 3 plus 1, 3 plus 1. And when you integrate, the du will completely disappear. When the integration sign disappears, the du also disappears. So after the power rule, you will get u to the power of 4 over 4 plus c. That is your integrated form. The last step is to substitute what you had in u back into the u. Sorry, this looks like a u, but it's a 4. Now, let me organize this. Okay, so I organized it. You wanna, as I said, you wanna plug back u into the equation. So it's x squared plus 1 plus 1. Don't forget the power. The new power is 4 divided by the same number, 4 plus c. So that is your integrated answer of this integral. This is your answer. Let's move on to a difficult one. Okay guys, so this is the second example, and this one's a little bit harder than the first one, but it's mostly the same. So here you want to pick your your u again, and remember, if you pick this, it can't be your u because it'll just equal to 1, and there's no 1 here. So you'll put your u as x squared plus 4. Now when you take the derivative of x squared plus 4, you'll get 2x dx. You know how to take the derivative normally, but here, when it turns into 2x, you'll notice that it's just x dx. You want to make it so that equals to just x dx. So one thing you can do is take the 2 and divide du by 2. If you get du by 2, then it'll just be x dx, and that matches to what you need. And you'll just continue the rest normally. I'll erase this now. So I organized the information, and now you're just going to continue normally by putting the du and the u in. Like normal, just put in the u to the power of 5. And then instead of just du, you have to put the du by 2. Okay, so there's no like check for this. Just know that if there's ever a denominator, just take it out directly. Just put 1 over 2 u to the power of 5 du. If you take this out, you have to take it out because it's going to get multiplied to the whole integral after. So use the simple power rule again for this. So it's 1 over 2 times u to the power of 6 over 6 plus c. That's your integral, and you can expand this after plugging in your u back. Or you can do it before, but it would make most sense to expand it after. Okay, so plugging your u back into the equation, 1 over 2 times x squared plus 4 power 6 over 6 plus c. Don't forget your plus c. And you want to expand now? It's just simple 12 x squared plus 4, 6 over 12 plus c. That is your integrated answer of this integral. Oh, sorry. Okay, guys, so that was all for today's video. I hope that U-substitution is easy for you guys. And if it's not, then comment down and I'll explain a few more examples. But that's basically it for U-substitution. It's pretty easy, you just need to practice it. And the next video will be about integration by parts. That's a little bit harder than U-substitution, but once you practice, you'll understand. Also, I want to mention that whoever comments first on my next video will get my calculus notes from last semester. Okay, so that's it for today's video. Bye, guys. Also, before I end the video, 96% of you aren't subscribed. Why are you watching my videos if you're not subscribed? Please subscribe. Thank you.